Thank you, Chair. Good afternoon, everybody. I hope I can gauge your interest because I think this is a fascinating subject, and I have the very great pleasure of talking to you today about a comprehensive nutrient programme on phosphorus that HGCA has, and to tell you what I think is actually very exciting new information. So why is phosphorus important? Well, it's essential for crops and for us. It's a major component of DNA, the surface of cells, in our bones. In short, it's a major nutrient, and we can't live without it. But there are issues. Some soils contain too little phosphorus, and others contain arguably too much. We've seen an increase in the number and length of P holidays. And if P indices are too low, then we risk reducing yields and reducing nitrogen fertilizer use efficiency. If P indices are too high, then there's a risk to the environment. Perhaps one of the biggest issues that we face, though, that is in RB209, we only have generic advice. It's undoubtedly good advice, but I think it can be improved. I won't dwell on the next couple of slides. Charlotte's mentioned it briefly as well. But over the last 10 years, the price of fertiliser has increased dramatically. I think perhaps more importantly, we've seen spikes in price that have really focused farmers' attention on the cost of these inputs, in phosphate in particular. Perhaps unsurprisingly, we're seeing yet less used on farm, and there's a real risk that we risk future yields because of what we're doing now. Undoubtedly, phosphorus can and is a source of pollution, but I'm not going to lecture you that this morning. Actually, far from it. I think that we should be very proud that water quality in the UK is actually improving. Having said that, I think we should all be vigilant. We have a huge responsibility as custodians of the environment, and improvements can be made, but I think we should be very proud that water quality is improving in the UK. If we think about how we manage phosphate, a farmer, based on the advice that you give them, will choose a type of fertiliser. They'll decide upon a rate, and that'll have huge financial impact on the farm. If you think about how much they're going to use, when they're going to use it, that'll have an impact on the environment that will ultimately, certainly globally, have social implications. If we think now about how phosphate's managed on farm, 10 tonnes of grain will contain around 80 kilos P2O5. We use fertilisers to supply crops with phosphate, fertilisers and other organic sources, manures or sewage sludge. The aim, the principle, certainly as laid out in ARB209, is fairly straightforward if taken at face value. The aim is that we maintain index 2, either building up or running down, maintaining index 2. Actually, it's a bit more complicated than that, and you'll be giving advice on a whole range of other methods and options as well. Won't just be broadcasting fertilisers, we'll be using seed treatments, placing those fertilisers, and then perhaps even using foliar applications as well. And currently we don't have information, certainly in RB209, not very much information on any of those other methods. So for me, there are 4 really important questions. Is target P index of 2 appropriate for all soil types? Can we farm at index 1 rather than 2? How can we make better use of recycled P? Sewage sludge is a great source of phosphate, but I think we could probably make better use of that. And then, an important question, if we are taking these holidays, is how long does it take for these indices to decline? HGCA has a really fantastic programme, supports a really fantastic programme. Over the last 4 years, we've built up and supported 3 projects. The first is a critical P project that began in 2009 and run until this summer. Second project began in 2010, targeted P project, and will run for another 2 years. And then I'm really pleased to say that HGCA has supported a third project that looks to build on and extend those first two projects to enable us to build up, data and information over a number of years. What that means is that I can present information today on whether an index 2 is an appropriate target always. I've got some preliminary data because we've really only just started this work on whether or not we could farm at index 1 and not 2. I think the answer to the third question is undoubtedly yes, but I'll only be able to provide you with preliminary data today. But I do want to talk about it because it is really important. And then perhaps the most frequent question I'm asked is how long does indices take to decline? Well, we've just started this work, and I think it's too early to say. The advice is to take soil samples every 4 to 5 years. As you can imagine, it takes some time to do that type of research. But I really look forward to coming back in a couple of years' time and talking to you about that. I've put that in there because I want to give you confidence that we are looking at that. So the first project is examining the critical level of soil P. This project's been excellently run by NIAB, TAG and Rothamsted over the last 4 years. And in this project, we've defined critical P as the level of Olsen P, the readily extractable soil P, needed to achieve 98% of optimum yield. Yield increases slowly thereafter, and making 100% is an unrealistic target. So we've defined critical P as 98% of the optimum yield. And so is a target indices of P of 2 appropriate for all soil types, as RB209 would lead us to believe? Well, over the last 4 years, we've run 6 field trials on a range of soil types in the top right-hand corner there, ranging from deep clays to shallow soils over limestone and chalk. When we began the trials, each of these fields was at index 0 or 1, and we then established a range of indices from 0 to 3, which enables us to test the critical level of soil P. We grew cereals and oilseed rape, and then measured the yield response to those different levels of Olsen P and to fresh P. The key messages, I think, are really, really interesting. In answer to my first question, at index 0 and 1, there is undoubtedly an increased risk of not achieving optimum yield. Conversely, some years, the critical level of P at these trial sites was at index 3. It's unrealistic to plan to build up to index 3, but I think it's worth bearing in mind. The message is that you reduce the risk of not achieving optimum yield at index 2, and I think that's really important when you're talking to your clients. I think this information for you is very valuable when you're having discussions about how your clients might manage P. But, there's always a but. Consider the soil type, and specifically its condition, because for some, an index 2 won't be an appropriate target. For example, we saw that on the shallow soil over limestone, where it was near impossible to build up and maintain an index of 2. There you're going to have to consider other options, and I'm sure some of you have seen examples of this because I'm frequently asked that question. I don't think it's never been more important to take samples and analyse those every 4 to 5 years, remembering that poor structure, and we've seen this clearly in these trials, will lead to a greater demand for phosphate and a reduced nitrogen use efficiency. We've shown that in these trials, fresh P can substitute for subcritical levels of P at index 1. Now, RB209 would suggest that that's not possible, but at index 1, we have shown that fresh pea can boost yield up to that you would expect at the index 2. Exactly how that will work in practice needs to be worked out, but I think it does. It hints that farming at index 1 might be possible if we can make better use of fertiliser. A part of the research project was to review data going back to the 1960s, and that's available on HGCA's website. If you perhaps want to Google HGCA Research Review 74, RR74, you have a lot of data in there that supports index 2 as a target. The new data that I've talked about this afternoon will be made available in a project report early in the new year. We'll be summarising that in an information sheet. So if you receive hard copy publications from HGCA, keep an eye out for that. If you don't, then I'd strongly encourage you to sign up for that today. So if we just briefly look slightly forward, look to the future, could we farm at index 1, perhaps on these soils where it's not and index 2 is not a realistic target? Well, we've been looking at this, but I must stress this is preliminary results. This is one trial in 1 year. They are preliminary results. I'll say that a couple of times. This is a trial run by ADAS in Cambridgeshire on a calcareous soil, where it was at index on the border between index 0 and 1, so fairly low. We looked at applications of fresh pea, and you can see that linear response there to phosphorus fertiliser. But I think what's really important here is the effect of placing that fertiliser, where we saw placement of fertiliser having a yield response of about 0.4 of a tonne. And I think this could hint at where you might want to, or where you may need to, farm at index 1, you can make much better use of phosphorus than perhaps we currently do. One of the things that we trialled within in this experiment was Struvite. So just for those of you that are not familiar with Struvite, we've worked with a company called Astara, which is a Canadian-based company, but you may have seen in the press recently Astara's first, the UK's first Struvite production facility. It's called a nutrient recovery facility that opened in Slough, I think it was the beginning of last month, where they're removing Struvite from wastewater in the form of a granule which can be used as a fertiliser. It looks a little bit like that. Very good quality product, marketed as crystal green. We've been trialling that product. There's relatively little of it made currently, but I think this is a sign of things to come. We've trialled that, and it looks as though it's a good source of phosphate. So I think it's something to look out for in the future. You may be offered it. We have started to trial it, and I think that it could be a nice, neat source of phosphate fertiliser. So the key messages, definitely, this is preliminary results. I'll say that just one final time. Struvite, crystal green, as is Astara's product, it certainly appears to be a really useful source of phosphate, and I think we could see more of that come onto the market in the future. Placing fertilisers undoubtedly increases the efficiency of use, and I think from what we've shown, the use of fresh fertiliser, if placed, really could help people farm at index 1 in as a real option. And I hope I've given you a flavour of some of the research that we're funding. I hope again to come back and talk to you about that in the not so distant future. I do need to acknowledge the partners, and Claire hinted at this at the beginning. I'm very fortunate to work with more than 30 different partners on phosphate across Europe, and they are responsible for all of the work that I've presented today. Finally, thank you very much for listening. If you would like any more information, then please visit hgca.com/nutrient management. If you have any questions, then please drop me a line. Thank you very much.
Thank you.